Hello, what's up? It's still me with a stash before I let it all go by today or later or tomorrow, whoever. But then basically for this video, we're gonna discuss simplifying rational algebraic expressions. So let's jump right into the topic. And for today's lesson, we will be guided by our dear crewmates in this thematic concept, which is the RAE among us. So we will have different tasks that we need to accomplish in order for us to learn better in relation to rational algebraic expressions. So let's start with our very first task, and that will focus on recalling on how to simplify fractions. Because without that, we will be having a hard time in order for us to understand how to simplify RAEs or rational algebraic expressions. We need to start first on tapping on to the lessons that we have learned before when we were young. That sounds like an Adele-like concept, but let's go. So we'll try to connect some wires here, and in the game you can already just put them all together by color. But the thing here is that we need to understand how we were able to simplify them. For example, you can see that 6 over 18 and 1 over 3 are equal. Basically, 1/3 is the lowest term of 6 over 18. Similar with 4 over 24, it became 1 over 6. 15 over 25 became 3 over 5. And then 14 over 49 became 2 over 7. Well, basically, when simplifying fractions, there are different ways of doing it, different ways of handling it, but what we will maximize here is the concept of the GCF, so that by the time that we simplify RAEs, it will not be a difficult skill or task to do so. So let's start with 6 over 18. When we look at these, we see that there's only one term, or a monomial, basically a number over a number. We can see that, or we can get the GCF of 6 and 18, and the GCF for that is none other than 6. So what we can do here to simplify this using the GCF, divide the numerator by the GCF and divide the denominator by the GCF. So 6 divided by 6 is equal to 1. 18 divided by 6 is equal to 3. So that's why it's 1/3. So that's the concept of simplifying with the GCF. For the second item, the GCF is 4. So 4 divided by 4 is equal to 1. 24 divided by 4 is equal to 6. That's why it's 1 over 6. To continue, we have the next one. The GCF is 5. So divide the numerator by 5. Same case with the denominator. You'll get 3 over 5. And next, for the GCF of this one, it will be none other than 7. So divide 14 by 7. Divide 49 by 7. You'll get here 2 all over 7. So that's it. So we're going to maximize the use of the GCF in order for us to simplify not just fractions, but also RAEs. So for you to have a much better understanding of what RAEs are, it's important for us to discuss the relationship of the two. Why are we simplifying fractions, and how is it related to our lesson? So now let's try to define what RAEs are, or rational algebraic expressions. So for example, you have this, which one is a rational algebraic expression? You have 1 over 2 and x over 2. In this given slide, the RAE is none other than x over 2. Similarly, if we continue, what's the RAE between 3 over y and 3 over 5? It's none other than 3 over y. And lastly, what's the RAE between 12 over 19 and 3xy over 5z? It's none other than 3xy over 5z. So for us to understand this better, to discuss this better, what makes an RAE a RAE and what makes a fraction? Basically, if we're talking about fractions, it's all about whole numbers in your numerator and denominator. But for RAEs, the situation is this. Your numerator can be an algebraic expression, and the denominator can also be an algebraic expression. There are cases wherein both the numerator and the denominator is an algebraic expression, but there is a case that only one of them. So basically, if you want to put this in a much lower use of vocabulary, not mathematical, you can just say that if it's RAE, there are variables or letters involved. Same case with other exponents. So if there's Algebraic, that's the word. You will see variables or letters. So without that, it's just simply a fraction. So to continue, let's now try to go to our next task, and it's to simplify rational algebraic expressions. So I have here prepared 10 examples, and let's answer them one by one. Okay, let's go to the first one. So the first one is 4x raised to 4 all over 12x raised to 5y. And I repeat, there are different ways of solving this, but what I would like to focus on is the use of the GCF. So you may take it in these different ways. You can take it slowly by identifying the GCF first of the whole numbers, since we're dealing with monomial over a monomial. So you have 4 and you have 12. The GCF there is none other than 4. So you can simplify this by having 4 divided by 4, and that is equal to 1. 12 divided by 4, that is equal to 3. To follow, after identifying the GCF of the whole numbers, start looking at the variables. So they have x raised to 4 and you have x raised to 5. Now, we can easily point out that they both have x, the numerator and the denominator. But to make this much better to understand, how do you get the GCF when dealing with this kind of example? It's pretty simple. Since they have the same variable, observe their given exponent. The lower exponent or the lowest exponent will always be the GCF. So in this case, it will be x raised to 4. So if you simplify x raised to 4 by x raised to 4, the answer is 1. X raised to 5 divided by x raised to 4, that's equal to x. Remember, class, when you're dividing, for example, x raised to 5 divided by x raised to 4, since they have the same variable, you simply subtract the exponents. So 5 minus 4 is equal to 1. And always remember, if the exponent is 1, you don't need to write it anymore. So that's the case there. So the final answer here will be simply 1 times 1, that's equal to 1. And the denominator is 3 times x times y, so it's over 3xy. So that's your final answer. So you have the guide questions here, but most importantly, we just focus with this one. But later on, the two questions will play an important role. And that's when we have binomials, trinomials, and so on and so forth. So let's continue with our next example for number 2. Now, we still have a monomial here. So let's try to identify the GCF first. Again, you don't have to put this quickly. You can do it one by one. Focus with the numbers. 16 and 24. The GCF is 8. 16 divided by 8 is 2. 24 divided by 8 is 3. Now, let's look at the letter A, or the variable A, since they both have it. Again, the lowest exponent or the lower exponent. So it's A raised to 3. So A raised to 3 divided by A raised to 3 is 1. A raised to 5 divided by A raised to 3 is A raised to 2. One thing that I also noticed is that some students tend to have a problem when dividing A raised to 3 by itself. Since they are the same thing, class, the answer will always be 1. It's like 2 divided by 2, that's 1. 3 divided by 3, that's 1. 1,000 divided by 1,000, that's equal to 1. No matter how big, how small, or how large the number is, or how long a term is, if you're going to divide it by itself, the answer will always be 1. Okay, always remember that. So earlier, I also pointed out how to subtract exponents when dealing with division. So a raised to 5 divided by a raised to 3. 5 minus 3, that's 2, so it's a squared. Next, we have the b's, and the lower exponent is 2. So b raised to 2 is the GCF for the letter b's. This will become b squared. This will become 1. So 2 times 1, that's 2, times b squared, that's 2b squared. Next, 3 times a squared times 1 is 3a squared. And that is your final answer. So that's how it works. Again, you don't have to identify the complete GCF immediately. You do it one by one. Start with the numbers, start with the first variable, the second variable if it's available, and that's it. So let's go with the next example. We have 23 and 46. So for 23 and 46, the GCF is 23. So divide that by 23, the answer is 1. Divide this by 23, the answer is 2. Now we have the q's, and the lower exponent is 1. It's this one right here. So q divided by q is 1. Q cubed divided by q is q squared. R and r cubed, the GCF is r, since that's the lower exponent. The answer here will be 1. The answer here will be r squared. Again, always remember, if there is no exponent indicated for a given variable, it is automatically raised to 1. So S doesn't have a partner, so just basically copy it later on. So you'll have Q squared all over 2 times R squared, so 2R squared. So that's your final answer. That's it. So let's proceed to another example. I think this time around it's now a binomial. Exactly. Now this is where the first two questions play an important role. Earlier, we were getting the GCF, or we are factoring based on the relationship of the numerator and the denominator. Now, we have to take it one at a time. So let's focus first in your numerator since it is now a binomial. So xy plus 3y, this has two terms, which is xy and 3y. We can get its GCF being y, because that's the one that they have in common. So to simplify this could be rewritten as, factoring out the y, you'll get y times the quantity, xy divided by y is x, 3y divided by y is positive 3. So that's now how it looks like. Similarly, the denominator is also factorable, and the GCF for 4x plus 12 is now 4. So this will be rewritten as 4 times the quantity x plus 3. How did we get x plus 3? 4x divided by 4 is x. 12 divided by 4 is 3. And always remember, class, so earlier we were getting the GCF, the numerator, and the denominator. Now we try to get or factor the numerator first, and then we factor also the denominator. And with that, we can now rewrite our given RAE as this one right here. And as you can notice, they both have x plus 3's, so we can simplify that, and the answer here is none other than y over 4. So what happens in this one? Basically, we can cancel out or simplify when they have something in common. Now, there's a specific rule here later that I will focus on, but in the meantime, if they both have it as a factor, you can divide that. So they both have x plus 3, that's technically their GCF of these two given of the numerator and the denominator. So the answer here is y over 4. To continue, let's have another one. Now this is 8a plus 4b. So let's write our numerator right here. And the GCF for this given is 4. So factoring out the 4, we will get 8a divided by 4, that will give you 2a. 4b divided by 4, that will give you a b. Similarly, if you have bc plus 2ac, the GCF there is none other than the letter C. So factoring out the C, you will get B, C divided by C is B, 2AC divided by C is 2A. And class, always remember, since this is addition, it doesn't matter which one comes first. You can arrange this properly, alphabetically, and this one will be simply C times the quantity 2A plus B. So to rewrite this properly, here we go. And as you can see now, we can simplify the 2a plus b because they both have it. So our final answer is none other than 4 over c. That's it. Let's have one more. I think we have 5 more. 5 more. Now let's have this one right here. A squared plus 2ab all over 6a. So the numerator is factorable. You have a squared plus 2ab. Factor out the letter a because that's their GCF. So this will now become a times the quantity. A squared divided by a is a. 2ab divided by a is 2b. So that's it. And now, again, your denominator is 6a. It's not factorable. It's just a monomial. So we just copy it right here. Now, earlier, we were canceling out or simplifying binomials because there are binomial factors that the numerator and the denominator have in common. This time around, we can notice that the GCF outside is a monomial similar with the denominator, and they both have a. That we can simplify. So this will now become as a plus 2b all over 6. So there will be a question like, sir, can we simplify the 2 and the 6? No, because the numerator is a binomial. If it's a binomial class, that means there are 2 terms. The denominator is just 1 term, and it's a monomial. So you cannot cancel that out. Again, the relationship of the numerator and the denominator should be the same, like binomial over binomial, for them to be simplified or canceled out. That's why here, since a, the GCF a is a factor that is monomial, same case with 6a, we can simplify that. Okay? So that's the important rule that you should remember. Later, we will have binomials that we can cancel out. Again, it depends on the given example. Let's head to that. Here we go. And speaking of binomials, here they go. The 2a plus b is not factorable, so let's just write it as it is, while 4a squared minus b squared is not factorable by GCF. Instead, this is factorable by difference of two squares. Since 4a squared is factorable as 2a times a for the first term, and for b, it's simply b times b. In this case, it follows the format of having the same factors with different operations in the middle. So this could be 2a plus b and multiplied to 2a minus b. This happens for a difference of two squares, and we just copy the numerator, 2a plus b. And I repeat, what we can cancel out here is the one thing that they have in common, or what they have in common. Here specifically, so you can notice they both have 2a plus b, a given binomial, in common, so we can simplify that. So what happens when you simplify a certain given, there's nothing left? It's equal to 1. That's like what happened earlier. When you cancel out or simplify, that means you divide it by itself or divide it by the one that you're canceling it with. Or depending on the GCF. It depends on that. Basically, when you're canceling, it will be equal to 1, or it could be equal to depending on what GCF you used. Since we use 2a plus b to divide the numerator and the denominator with, it'll be left here with 1 over 2a minus b. That's your final answer. So it's also important to remember the different kinds of factoring techniques that we have done in order for this to be smooth. So let's continue with number 8. Now we have a 3a minus 6 for our numerator. This is factorable by GCF. The GCF is 3. So this will become 3 times the quantity a minus 2. While the denominator is an example of a general trinomial. So we have to think of factors of negative 6 that if you add it, it's equal to positive 1. So in that case, we already know that this is a plus times the quantity a minus. Because again, negative 6 is a product of one positive number and a negative number. Since the middle term is positive, that implies that the higher number is positive. So what are the factors of negative 6 that will give us a sum equal to 1? That's none other than positive 3 and negative 2. So this is now our given RAE. And as you can see, we can cancel out or simplify the binomial factor a minus 2. So our final answer here is none other than 3 times the quantity a plus 3. And I repeat, we cannot cancel anything out here anymore because the numerator and the denominator are different. The numerator is a monomial, the denominator is a binomial. So we cannot cancel out the 3's here. Always remember that. Basically, to put this into perspective, we can cancel out like binomials, trinomials when it's put into like a parenthesis at times. That will help. Like the a minus 2's here are both in parentheses. You can take them as 1, and this will be applied later on our next example. Let's go. 9. Okay, another example of a general trinomial. We have x squared plus 6x minus 7. This is a general trinomial, a gen tri. And we have x squared minus x, simply factored by GCF. The GCF here is x. So this will become x times the quantity x minus 1. While for this general trinomial, we think of factors of negative 7 that if you add, it's equal to positive 6. So since the negative 7 is negative, 1 must be plus, 1 must be minus. Since the middle term is positive 6, that implies that the bigger number is positive, so we can have positive 7 and negative 1. So 7 times negative 1 is negative 7. 7 plus negative 1 is equal to 6. So we can cancel out the x minus 1's, and the final answer is x plus 7 all over x. I repeat, you cannot cancel out the x's here because the numerator is a binomial and the denominator is a monomial. So that's the rule right there. And for our last example, for simplifying RAEs, we have this given. So if you look at this one, you might find it complicated and you might panic. But as you can notice, there is a monomial factor, a binomial factor, and a binomial factor below. So here we can actually apply either GCF technique, cancellation, simplifying, or dividing them, whatever it may be. So we could start with identifying the GCF of the monomial factors. So 27 and 9, the GCF there is 9. So this will become 1, this will become 3. The GCF of x and x cubed is simply x. This will be 1, and this will be x squared. So some are panicking if they see something like this, like the quantity a minus b raised to 2 and the quantity a minus b raised to 3. As you can see, class, they both have the quantity a minus b. So that could be a greatest common factor for them. But what should be its exponent? Similar with earlier, the lowest. So it should be the quantity a minus b raised to 2. So this will become 1, and this will be quantity a minus b. And that's it. So your final answer here should be 1 over 3x squared times the quantity a minus b. You do not need to distribute 3x squared because that will defeat the purpose of factoring or simplifying or putting it in simplest form. So this should be your final answer. And that's it basically for simplifying RAEs. Always remember the rules. You can only simplify if it's monomial by a monomial, binomial by a binomial, and so on and so forth. So that's how you simplify RAEs. And that ends our video lesson for the day. Hope you guys learned a lot. And I think Coco learned a lot, right? Did you learn a lot, Coco? So in case you want to check out some of the lessons, especially now that we're simplifying, multiplying, dividing RAE, it's important to go back to some factoring lessons. Make sure to check out the videos that were prepared last time so that you will be refreshed with the topic. And that's it for me. And in case you don't see me, good morning, good afternoon, good evening, and good night. Bye bye. Peace out. Respect.